Good evening. Today we're going to cover Fusion 360 to CNC, specifically for the Shapeoko 3 XL. And one of the biggest differences between this approach and maybe sending to a 3D printer is 3D printer is pretty streamlined. Given any new project, I mean, you'll make a couple of changes or a couple of different decisions. But when you're throwing something at a CNC, or in this case like a milling operation, every single time you approach it is kind of a new design project. So let's jump into that. So I've got my model in Fusion 360. We're doing just the top. We're not going to do index or two-sided. Got a little sculpt object going on. So one of the things I want to be aware of is the origin. Think of the origin as where does the bit on the machine start. In my case, it's top right. Sometimes it's top left, bottom left. Just kind of keep your mind aware of its orientation in relation to your model. I can change this up, but just my history with setting up CNC machines is this guy is very important, because if you don't know where the bit's coming from, it's difficult to know if it's going to land on your stock material. Okay, so we're in the design phase. I'm going to add two features right now. I can justify them later, but it's easy to start off with them in the beginning. The first one is I'll add a sketch. Essentially what I'm doing, I'm creating an outline, right? Sketched, top layer, now that I know that is flat against the origin. And I just did, see, 12 different sides. I want to give enough room for my bit. We'll go into bit measurements and the importance of bit measurements in just a little bit, but enough room for that bit to slide in between my model and my boundary. And the second thing is I want to create a connector. Pretty simple. Half circle, extruded through. One of the big reasons is if you're doing a cutoff pass, like you're cutting through the entire stock material, well, once you get to the very end, like what's holding it? Nothing. I mean, you could have taped it down. A lot of what I'd use is like screwing down or compression. But once you cut it away from the material, it's going to fly away. And so you end up with like a big old like gnar or a chunk missing out of it because the bit was still spinning. It became loose and moved out and kind of just bit it. So what I like to do now, if I know it's going to be using a kind of final pass, is throwing a little connector through it. Doesn't have to be much, but something where I can hold on. You can cut that out later. So I'll talk more about these when we get there. Next thing, we will go over into manufacturing. So awesome. It is awesome. It has this capability in this program. I think I used Visual Meal back in the day. It was like I have to pay more to do something that makes me enjoy 3D modeling. Yes, very true. Okay, first thing I had to do was set up my machine. You do it by setup, new setup. But you come in here, right? There are some samples that are existing. If it's what you use, fantastic. In my case, I wanted to use my stuff, so I came in here. I'm just gonna show you the editing. How big is the entire machine? How big is kind of the workspace? Everything on my machine is done in millimeters. Kind of found that earlier. There's something that was bad with the math when I do it in inches, so everything I do is millimeters. It's a pretty basic machine. X, Y, and Z. The router is not a spindle. A spindle is this motor that you can adjust the speed with the computer or with the programming. In my case, it's like a basic router you get at the hardware store, so I have to adjust it with a little dial. And for the stuff that I'm doing, it's not that professional. It's more hobbyist. Works fine. So we're not really setting up a spindle. Coolant. At some point, I might have suction or I might have air, but most of them I don't. Flood would be, awesome if I was doing aluminum, but I'm not. So a lot of times I'll say, coolant, nothing. Post-processing, this one's rather important. When I spoke about the 3D printer, they all have their kind of own proprietary software, and this is the case, right? I'm using a piece of software to create what's called a G-code, and this G-code has to be interpreted in a certain way that the machine knows what you're talking about, because it would be nothing worse than like flipping the Z or flipping the X and it going in the total wrong direction. Setup sheet, multi-axis, never mess with it. So my machine's ready to go. Most importantly, I have that post-processor selected. We will be doing milling. It's crazy. It can do cutting, additive, and milling and turning. I'm just doing milling, in this case, 3-axis, X, Y, and Z with a bit. Working coordinate system. You see all these little dots? These are kind of pre-given opportunities for you to set up like where the home should be, where is 0, 0, where is the origin. And I could adjust around like where my box is, have it based on just this piece of geometry. In my case, I'm setting up for my stock material. So let me double check that you can see what I'm working with. Got some insulation foam, came from the hardware store, cut it down into 12 by 12. I'm not cutting the entire 12 by 12. What I'm doing is I gave it half an inch on all the sides. So really I have an 11 by 11 inch surface to work with. Quick conversion over to millimeters, 280 millimeters on my X and Y. And then my Z, we'll call it 50. It's closer to like 48, 49, but we'll call it 50 millimeters just for easy number's sake. So I'm going to take this guy and input it into my stock material. Do we have a lot of information inputted? So stock material 280, 280, and 50. Okay, so it's the right size. The only adjustment I need to make is I'd like the new origin, this new stock, to be sitting on the original origin 0, 0. I need to adjust this measurement. Let's try 90. Top view. We're close. Okay. So it's sitting on my origin. I'm not sure if this is like necessary or not, but I kind of coming from how I learned it, I want that security. So now that the stock is set, where do I want my origin? Where do I want my 0, 0 to be? Some people prefer it to be at the middle, and like I showed you earlier, I kind of X'd out this piece of material. If I wanted to go from the origin, I could. But once you start machining, especially if something's in the origin, you lost where you can go back and reference. I try to put it on an edge now. Yes, you can buy pieces of machinery that, go ahead and 0, 0 out your material based on new stock. I kind of do it the old school way. So I'm going to put my bit on this corner, machine something else, and if anything goes wrong and I need to like change a bit, I break a bit, make an adjustment, I can always go back and find that 0, 0. So I'm not going to lose it by machining it. So anything else? Modeling, yep. The model is that model. I need to know that it sees it, which is going to be especially important in these next few steps. So setup looks about right. These numbers are going to be different according to what material you're using, but you need to be aware of them. Post-processor set that up, and we can change naming protocol at the very end. So now that our machine is set up, we need to pick some fabrication approaches. 2D is really cool. The Shapeoko 3 comes with its own kind of proprietary software that is pretty good 2-axis cutting. 2-axis, think of it kind of a laser cutter, right? So it's going to drop down and cut the entire way through. You can like consider like a 2.5 drop down cut, drop down cut, drop down cut. 3-dimension has your flowy all 3 directions. So we're going to stick in this one because that's specifically what I need it to do. Checking notes. All right, Jumping into toolpaths. I would love to just go straight over into parallel finishing. And what it's going to do is, well, I'll show you and then I'll come back and say why it's a kind of a bad choice to do in this situation. So my tool, I need to select my tool. I'm going to blow through this because it's not the approach here. Disabled feeds and speeds, not going to get into that yet. I'm just going to do parallel finishing within my boundary. Fine, double check. Okay. I'm going to let it go and make this toolpath. All right, we're good. Like, yeah, the streamline, we would just go ahead and do this. If you were an additive, not a problem, but we're not additive. We're taking material away. So let me show you where this becomes a bit of an issue. We've got this bit, and yes, I'm using foam, and it's very forgiving, but it's just kind of a bad approach when you're going to take your entire bit and just crash it through a material. Could foam break a bit? It could. You'd have to do something pretty rough to it, but so let's see if we're going to run this toolpath. Bring it back to the beginning. And material back on. Just want to run it slowly. Right, you see how much we're plunging into the material before we actually start cutting? That is a lot of stress on that bit. And if you want to have an unfun day, you go ahead and break your bit in your first pass and you don't have an extra one and you have to order it, which is going to take at least 2 more days. So since we don't want this approach, what I'm going to do is I'm going to do a roughing pass. I'm just going to remove material that I don't need, and then I'll come back in with a finishing pass. It could be parallel finishing. We're going to use a different one today because of this shape. But you want to avoid doing this. It's just not good for your machine. It's not good for your bit. Too much stress. So close this and get rid of you. All right, so we know we need to get rid of some material. These are for getting rid, clearing, as they call them, and these are more for finishing. Pocket clearing is kind of the one that I grew up with. I like how it drop downs in sections, drop downs and cut, drop downs and cut. It takes a while. Adaptive clearing, the ones I use now, but I don't know like how to explain how it works. Other than I'll show you. All right, we're going to select a tool. Now, if I'm clearing, I just want to get rid of as much materials as I possibly can. My machine, it uses a 1/4 inch bit. So if I was doing this the perfectly right way, so we got this guy, 1/4 inch flat mill bit. If you've seen CNC furniture, like this is typically the bit. I'm over exaggerating. This is typically the bit that they're going to use, but 1/4 inch across, it's got about 25 millimeters of cutting range. It's maybe 50 millimeters tall, and yeah, 2 flute, 2 different spirals that do the cutting. So that's what I would typically do a clearing path with, or something bigger, right? I'm just trying to get rid of material. I don't want to take time doing that, but I don't have an automatic tool changer on mine, so I'm going to make my life a little bit easier by being just lazy. I'm going to use a 1/4 inch ball mill, so flat. This one's ball. A little bit shorter cutting area, about the same over full body length, but using these dimensions or using these measurements is extremely important. If you mess these guys up, especially your width, like how big is the ball, you're going to get some pretty interesting results. I have one more bit I wanted to show you. I don't use it often. They are more for detail, working on really small features, and when it's a small feature, I have to make the choice of, do I want to go CNC machine or do I want to go router, which is almost durability, materiality choice. Here we go, trying not to make a mess. I've got a bunch of these, so 1/8 inch, and because my machine accepts only 1/4 inch, I have this little collet grabber, so it allows me to extend up into my machine. But right, I'm not going to do any clearing with this, but if I needed something small and detailed, this guy would work. And because it is so small, I typically have multiples of them. If your range for error is less when it comes to durability, just because it's smaller. I have stuff that's even smaller than this, but that's a different story for a different day. Let's talk about installing this information for this bit. So many wonderful options. Here, I just want to edit so I can show you the approach to editing. What do I use to input information? Caliper, right? You can trust this because it's like that's its job to give you the measurement. So I didn't use this one on my pass. This is kind of like my backup. It's got 4 flutes. The one I traditionally use is 3. And I'm simply going through and saying, all right, what's the size? Input the size all the way up. Is there anything else on this one you really need to know? Flute length, like how much can actually be cutting, is rather important. For the bit I'm holding in my hand, the flute length is 20. We'll call it 20 or 19. I don't want to all of a sudden throw this 20-inch further than 20-inch, because if it's cutting and drops down to, like, we'll say 30, I'm essentially just rubbing fast spinning metal into the foam. Once again, not good for the bit, even worse for the machine itself. So being aware, like, how much is going to be engaged when it's cutting. And yes, you can buy ones that, you know, are spiraled all the way up, more expensive, higher chance of breaking. So choose as you will. I don't have any shoulder lengths. I don't have mine that taper off. So essentially what I do is the diameter, the entire way up is going to be 6.35 mil, quarter inch. And I'm just inputting overall length, same thing for body length, same thing for shoulder length, because it's straight, there is no taper. All right. Cancel, I didn't make any changes, but yes, we're going to use a ball mill, not traditional, what you should use for this clearing pass, just so I don't have to change the bits out later. All right, so we got our tool. We don't have any coolant, so I'm disabling the coolant. Feeds and speeds. How fast should this bit spin, and how fast should it eat through the material? Great questions. Then you're like, why? If it's so difficult, why would anyone do this? Because sometimes you need different materials than what's available to you on a 3D printer. Plastic is great, but plastic is great. I'm definitely relying on information from people who are way smarter than me. Spindle speed. Keep in mind, mine is not a spindle. It's a router. So it's going to run maybe 2,500, 20,000 RPMs. Surface speed. How fast this bit is moving across the surface. So think about it like if it's not spinning at all and moving through, that's not very good for anybody. If it's spinning really fast and moving slowly, that's okay. You're getting lots of friction, not really good for the bit, but that's okay. A little bit less okay is if it's moving kind of fast, but not spinning fast enough. It's still like getting bits out, but not doing its job. So try to get a resource where there's a balance. I'm going to show you what I've been looking at today. So I Googled feeds and speeds, really good article here by Will Adams. And I clicked on the one, I think down here. Yep, Shapeoko Wiki materials. And you can go through and find the materials you're going to be using, and it has all the information kind of laid out for you. So you don't really have to understand them, you just have to input them. What I'm doing is, since it's not totally high, let's see, it's low density, it's soft. I'm going to make mine like cork and start copying those bits of information over into feeds and speeds. So RPMs, 24,000, pretty fast. And I can change these anytime I want to because I don't have a spindle. The spindle doesn't need this information. I'm just going to adjust the button on the machine. Let's see, what's next? It's going to say I'm going to run it at a 5 on the machine, a number 5. The next thing, feed, right? So as this thing's moving through the material, it's feeding, right? You call it cutting speed. So I'd rather go too fast than too slow, but this is a kind of ideal number. So 60 inches or 1,524 millimeters. So we're going to throw that dimension in. Cutting rate 1524. Got it. Plunge feed rate. Plunge is I'll get down to step down and step over, but plunge is how fast it's going to drop into the material. A lot of times I'm going to run my plunges, if I have control over them, very slowly, making sure not to go below the teeth, and then move over. It's simpler. Other approaches will have it kind of ramp in, so it'll slide in, but we've got the information. We're going to insert it. So 762 on my plunge feed rate. Anything else, right? I consider the surface speed. So how fast it's expecting it to like eat, and then how fast things are. This is how fast it's turning per se. This is how fast it's moving. So you put those two values together and then you get your feed rate. This one is at 484. Mine is at 476. Same ballpark. I'll leave it right there. In terms of geometry, it's going to ask, all right, we got to move material. How much material do you want me to remove? That's why I went back and I drew that line. Do I want it to remove every single thing? Because it'll do it if I ask it to, and it's going to take forever because it's got a drop down cut, drop down cut, drop down cut. I'm not even going to simulate this because it would take forever. You can do silhouette. Silhouette's going to choose the silhouette of your object. In this case, I already have a selection, so I'm going to select that curve to be my machining boundary. You get the option to, do you want that bit to always stay inside of the line, be on top of the line, or have the ability to go outside that boundary? Right now, we'll say center. Any additional offsets, no. I don't know a lot about rest machining or stock contours or tool orientation. I believe we ought to have our model selected, but just making sure. Good. Now, heights. You got a couple things to look at here. The bottom should always be the bottom. There are exceptions, but the bottom should be the bottom, and the top should be the top, right? Bottom up, bottom height, top height, stock top, and model bottom. Let me describe what some of these are. Clearance height. Right when the machine starts, it's going to go as high as you have for clearance height, move over to where the model is, and then drop down. So we don't want this to running into any clamps or any other geometry you might have on there. So typically this is the highest one. Retract height is if you have two spots that it's going to be machining out of. It's going to go to, visual aid please. It's going to finish that section, come up, over, and then go back. So the height it goes to in that case is the retract height. Top height, I'm okay with it being the stock top because it's got to work through whatever is there before it gets to what will be my model. If I started on model top, I might be chewing up too much material that it doesn't know that it's there. So these guys looks pretty good to me. This next one is passes. Optimal load, I'm not 100% sure. The definition of this, I know what step over is. So this is my assumption. This guy is 6.2, I think that's the number, millimeters across. In terms of step over, it's going to cut a line, and then it's got to step over for the next one, yeah? So it's going to cut a line. What percentage should it step over? The max you can do is 100. 100's a pretty big amount of stress on the bit. It could still do it if you're not going for really high fidelity. If you're going for like super high detail, you do a line and then you step over maybe like 5% or 7% of this, right? Mere millimeters. So you're getting really high accuracy. You're not going to say anything, but then again, it's going to take a long time. I like to go with 50% step over. So if this is 6.5, I'll have it step over 3.25 every single time. It's a good number for me. If I want more detail, maybe I'll go 20. I've never gone to 10. I've never gone to 7, only just because I'm kind of impatient. So I'm going to bump up my optimal load up to, we'll call it 3.25. And then step down, like I said earlier, a rule of thumb, if we had a more dense material, is you only want to step down half the size of the bit. So in inches, if this is a 1/4 inch bit, I'm going to step down 1/8 every single time, right? Keeps the load off of this. If you step on a whole bunch, it's going to want to kind of bend this guy. We don't want to have it bent. We want it to stay in one piece. Because we are doing this method of removing material, I'm allowed to drop down 10. I've got the space to do 10. I know it's foam. It'll work. All right, that's good. I would tell you what linking is, except I don't know what linking is, so I'm going to ignore it. Once I hit OK, it's going to process this toolpath. It's got numbers here I'm processing. All right, so that's my first round. And it's going to do a lot of work on this pass. That way when I go back and do a finishing pass, it's easy. It just glides. Removes a little bit of material. We are almost at 60%. All right, so first level's done. Second level's done. It's going to do this all the way to the bottom. There we go. And we zip through and we are done. Also, the thing about this program is being able to preview, right? I can see mistakes before I make them, have to come back and do things. So simulate allows me to jump into a virtual environment where I can see if my numbers are correct, this accurately shown, that accurately shown. I can have a material that's transparent or full opaque. Anything else I need to see on this guy here? No, I think we're good. One of my things, it's great that it knows how fast it's moving. So currently this will take 34 minutes, right? Less than 3D printing for sure. All right, we're digging in, we're removing material from the outside. We'll leave it like this. And so what this toolpath does, it maximizes the stress it can put on the bit without kind of overdoing it. You see it's kind of taking one direction. Because you have the flutes going in a certain direction, you can have upcut or downcut, or conventional downcut, or conventional upcut, unconventional downcut. So when it spins, it's always pulling material up and out. You can have a compression spiral, pushes it down, more things for another day. But it's going to be using that kind of same direction to remove as much material as possible without putting strain on the bit, or unsafe strain. So we did a lot of work on this, right? That's 30 minutes worth. It looks like my model's almost done, but I can do better than this. All right, so we moved a lot of material. Fantastic. We'll close that for the moment. Now we got to go back in and make it a bit more pretty. Traditionally, I would do parallel finishing. All right, no coolant. All my numbers are correct. Still stay inside those parameters. Heights are the same. Passes. This whole step over here, very important, right? I'm stepping over half. I'm going to do a quick look at what that might look like. There's good and bad things to this approach. Everything kind of falls in this direction. It's going to look fine, look pretty accurate. But the more steep this gets, the more inaccurate it becomes. I'm just going to simulate this one. Where you're seeing this red is where my collet, my holder, is running into the material. This is not good. We typically want to avoid this. One way is to get a longer bit. Another one is like move material around, or I could expand my area, right, to take into consideration my width of my collets maybe an inch across, so it's not as drastic as this. So do I like this outcome? I mean, I think in certain situations, like this looks good, but I don't like all this spacing that I'm missing over here. So I think there's a better toolpath. And I want to make sure we're taking into consideration my rafts, my connectors. I don't think we are. I do know a way to fix that. You go back into design. I don't want to move the group. I just want to edit this one feature. There we go. Set a new body. Join you up. All right. Jumping back. It's like, hey, something's changed. What we're going to do is, one, I'm going to check my stocks. We bumped over a little bit. We are not doing that. Let us change my offset. I believe 70 is my magic number. Oh yeah, very nice. All right, back to where I was. In order to get this guy back where it's not an error, I'm going to generate that file again. It's going to take a little while. This one, we already kind of talked about how I wasn't so happy with it. Right, I don't like this part being a little bit less descriptive, and we missed that. So let's not do parallel. In this case, I'll try whatever starts to look good. My second one that I went after was a a spiral. So same everything. I don't use these a lot, so some of these words are a little bit I don't understand what they mean. But if it was going to process that, what might it look like? Right? Good detail up here, really bad detail down here. So we're not going to go spiral. And two more. One is a radial. Center point. Machining boundary to my selection. Let's see, how would it go about doing this? Oh man, incredibly high detail. Two issues. One is that's not going all the way out. I believe there's a setting that allows me to change that. I don't want to center. I want to let it go outside the boundary. Still not getting to where I want it to be. The other issue is, you see how much overlap? This is like 1% overlap in here. So this would be like just perfectly smooth, and that would be pretty nice. But it's wasting a lot of time by having this all perfectly smooth, because there's a level of good enough. So we're going to get rid of radial. And the one that I knew we were going towards is kind of for me is scallop. Some information is good. Selection. I'm going to let it go outside the boundary. And like, this is the design part of it. I'm having to go back and forth and like take a look at it, go, do I think this is good? Do I think it'll work out nicely? Passes, step over, all right, going both ways, up, down, milling, don't really care. Like it can, right, we talked about there's a preferred, like you'd want to be upcutting, so I want to be moving into the material. I can cut to the left, and that works good. I can also cut back to the right. Typically likes one direction more than another, but it can do both. So let's run this scalping and see what it gets. All right, I'm liking this. So, right, I'm holding detail on the bottom. It's jumping over my my connector. It's going a bit too far outside. It's going to make it cut through all that material. It's not as bad as that first parallel finishing, but I do know how to fix that. That involves us coming over here and adjusting, let's say inside the boundary. Process one more time. All right, so I'm getting all my cuts. There is one more detail we could look at. I'm going to go ahead and simulate this. Can't see nothing. There we go. Turn that up, turn the transparent off. We kind of know what we're already getting. My biggest question at this point is, what is it doing about my connectors? Right? Got to be aware where my collar or my holder is. At this point, like, we're close to being cut out, right? You see how the tip of my ball mill gets down to 0, right? Even with this plane. But if it's right there, that also means that this is not really cut out. And because it's not cutting out the section, I don't need the connectors. There is a way to address this. Pretty simple. I'm going to take my bottom height and drop it down 2. Right? It means it's going to cut below my model, but by cutting below my model, if it was that flat bit, would have been perfectly fine, but it's not flat, it's rounded. So I need to go a little bit further to get the cutout. If you don't want to get the cutout and you want to like clean it up later, totally more power to you. Let's see if we can zoom through this. Fast speed. You ain't gonna show me the tool or the toolpath. I just want to see you go faster. And it didn't matter. In that sense, like, I would call this a spiral, right? It's stepping down once it gets back to where it started. Maybe not true spiral. Maybe it's kind of a 2.5 axis. 2 axis in the fact that it stays on a plane, but half in the fact that it drops. I think we might have got that cut through. All right, we're sitting on that line. I think this is one that I would roll with. So great. We'll close you down. The last consideration I need to do is, how do I take what I've done here and export it so the machine knows what I'm doing? What I'm going to do is, whichever ones you throw out. So if I want this all in one big G-code file, I'll select both and then I'll hit post. But because I like being incremental and they get step 1 done before I do step 2, I'm just going to export them as 2 different objects. So just the adaptive cutting. We're going to call this bowl adaptive clear. And I like to have dates. So 4.1 at, what time do we have? 1:23. All right. That way I can, like, if I make any changes, I know when I made the changes. I know which one is the most recent one. And in terms of where I'm going to put them, I could put it in this user data function, but I want to be able to find it because the next step is to actually use it. So I just throw it into my CAD folder. All this is .nc stuff. All right. Take you to where it's at. This was bowl adaptive.nc. This next one, I'm going to take just a little bit of second, kind of stop the video and restart the video, because I would love to show you what it looks like inside of carbide motion. But until I connect to the cutter, it's not going to let me access that interface. All right, we repositioned myself in the shop. We're done with you. What I need to do is open this carbide motion. I plug the USB into my computer. I'll connect to the cutter. And there we go. The first thing really it's going to make me do before I do anything is it needs to find home. Nice, it has some limiting switches, but what is its 0, 0, 0? So I'm going to let it jog, begin homing sequence. Get a little. There we go. Just fitting like it should. All right. So it's good on it. That is its new X, Y, and Z. As you see, I'm going to maximize here. These are the numbers that I used last night. This is its offsets from my 0, 0. So I'm going to go around here. What you can see through my other camera is I have kind of some holding stations, holding material down. Have what I had earlier. Essentially what I've done with these pieces of wood is I'm just kind of having them angled, kind of stabbing into the foam. It's a little of a lazy approach. I could like tape it down if I so desired, but what I chose to do on this round was to have these clamps, and all these guys are essentially homemade. So I applied pressure, screwed that down, increased pressure, so that way it's trapped from side to side, and this one traps front to back. So what I needed to do was set this bit to that point, because that's what I said 0, 0 in the machine, correct? So back into the interface. We'll be slow about it. So I'm hitting left on the keyboard, or this button. I don't want to run into a material, so Z is going to come up. We are at a maximum of Z, right? This is the issue that I ran into this past evening. Was my material was too big for what I was trying to do. I should have made it a bit smaller, saved a headache, but like I said, it's a bit of a design process. So what I have to do, man, I'm not far off it, but right, slide that up just a bit. The reason why I can't just home it out right now is, do y'all remember the retraction height or the clearing height? It's going to want to go up above the top of the material that I set up earlier. So if I was going to run this, I'm like, well, I don't have that 10 millimeters anymore. So I'd have to go back and change those numbers based on my machine and based on my situation. But we're not going to do that. I'm going to kind of continue with the process. All right, that looks pretty good to me in terms of X and Y. I don't want to stab into my material. That'd be a little bit embarrassing. But in terms of like, how do I get the Z? Because I want it to be just touching the surface without crashing into it, is I'll change to millimeter. And I got to keep my finger on the mouse so I can do this. I'll use a Post-it note or a piece of paper, not cardstock. And all right, that's too far. I'm gonna switch over to a fraction of a millimeter, and here we go. Right, just when you have the ability to move the paper, like it is under like its grasp, that's when you take it out. So I use this as an ability to make sure that my Z is consistent on whatever material that I use. All right, So my X is there, my Y is there, my Z is there. So that measures the input that I had on the computer. Now I've got to set that to 0 because right now it's using its 0. So if I 0 all of these, that means now the machine matches what I did in my computer. Is there anything else that I need to do? I can show you once you have this zeroed out. If like you need to go and do something else on the machine, we'll say we'll do kind of a rapid position. That's fine. I'm gonna bring my Z up just some more before I do this. I just remember this kind of an old school machinist taught me this one. I want to go back to 0, 0, 0 instead of like having to wiggle back in here. I'm set. I'm ready to go. MD has manual digital input. G0, X0, Y0. In this case, Z0. Oops, I'm not inputting zeros. Capital G. X0, Y0, Z0. This is the fast way to do it. If you can do the slow version, it's G1. Fast version is G0. But when I hit go, it's going to go exactly to where I told it to home to be. Just like that. Makes you a little nervous. All right, so we would load our file, our NC file. Full clearing. Two things need to happen. One, kind of make sure everything's all tightened down. Second one is close the lid on this box, keep some of the sound in, keep some of the dirt in. But what I like about this program is even say, all right, and go. The first step is go, hey, quick question, did you turn the bit on? In this case, I would go up, flip my switch, and then it's going to start running. I have the video captured in another file, so I'm not going to. I'm just going to conveniently quit. And so that takes us all the way from getting your file positioned to near starting it on Shapeoko 3. Wanted to walk you through a little bit of what you're seeing here. So when I said model bottom, it's typically model bottom. I kind of bent that rule a little bit. What I didn't want it to waste time, so essentially what I asked it to do was take the model bottom, move it up like 26 millimeters, kind of halfway through the model. Just knowing the kind of geometry, how much load I could put in the bit, and that it's foam, breaking the rules. So I let it take the material off the top half, and just kind of went ahead and did the roughing pass. This is the finishing. This is the scalloping toolpath that I chose. On second thought, I don't like the kind of meniscus effect. It's a bit too big, and this option could have took it down to maybe 15. A change in maybe 10% would have cleaned it up. Alternatively, I could just sand it, make it all smooth, and this is what we have as a final outcome.